Part E.2, exercise questions, set number 8. All right, the first question. When we solve a mathematics problem, or, our algorithm problem, computing problem, okay, we can put in the same category. Is it possible to use the mathematical induction to find the solution? So here, this question is designed to check if you understand one important strategy we used in problem solving: guess and verify, right? So that strategy we apply many times. Okay, guess and verify. All right. Guess is very important in problem solving. Before you know the answer, before you can derive the answer, if you have plenty of clues you can use to, guess, the result is very likely to be in some special way. So then it will make problem solving much easier. Because if you can see, if you can view, if you can imagine some kind of destination, you can see it. Okay? You can work toward that direction, then it will be much easier. Otherwise, you don't know where to go, right? If there is no destination, you don't know where to go. So that will be very hard. So this guess step is very important in problem solving. But after you guess certain possible result, you need to verify it. If you cannot verify it, then you do not know if it is correct or not, right? You have to do it. But the mathematical induction is a powerful way to verify. Okay? So it is a powerful tool to verify if the result is correct or not. Okay? So that powerful tool, although it looks like you can only verify a given result, but you can use that way to find unknown result. Because when you dig more and more clues from the problem, you can see the result better and better and make your guess. If it's not correct, modify it, verify. So not correct, modify it, then verify it. This kind of cycles, and eventually you can find a solution. So this kind of thinking is pretty common in problem solving. So this question is designed to check if you know that kind of whole strategy, All right. Is it possible? Yes. Right? In the examples in this class, we use the strategy many times, so you can get examples. All right. Now, that's the first question. Second one, smooth function. Smooth function, yes, do not use the calculus smooth. The calculus smooth derivative is continuous, right? Derivative is continuous. So there you see derivative, yeah, continuous, right? But not here, not in our algorithm class. Our smooth function, we have a different definition. Yeah. But for the definition, the formal definition, quite long, many lines, many conditions, descriptions. But the key condition, here I only want to talk about the key condition to check. We just check this condition, okay? The key condition. But there is another one that relatively easy to check. Eventually non-decreasing function, right? Eventually not, yeah. So this is eventually non-decreasing. You check that first, okay? Eventually non-decreasing. Yeah. Yeah. All right, the first condition, yeah, because usually this step very easy, so we do not need to spend much time on this. But this condition hard. So this condition, what is that? Yeah. F of 2n, f function of 2n belongs to big theta of f of n. Here it's very easy. Yeah. F of n equals n cubed. F of 2n equals 8 times cube. So this is a constant. 8 is a constant. Okay? Yeah. When you change the problem size, you do not change that 8 constant. Yeah. And we know 8 n cube belongs to big theta of n cube. That means this is a smooth function. You do it in this way. Okay. All right. Next example. Yeah, this time I give you a much harder function. So this time f of n equals e to the n plus 2 to the nth. Two functions. Two terms. Yeah. We want to check we need to check. All right. Now this time, oh, sorry. Yeah, this time f of 2n e to the 2n, right, plus 2 to the 2n. How about that? Compare with f of n. Okay, all right. Can you see? Can we get that? Yeah. Because big theta, remember, big theta, we have another way we can use limit. Limit to look at big theta, right? Limit. Okay, so here, let us use limit to see the ratio of these two functions. All right. Why can I observe? All right. 2n, right? Yeah. Ratio of this one. Can you see? Can you see how big it is? Yeah. All right. So let me divide it by this term, top and the bottom, to the n plus 4n over e to the n, right? 1 plus, right? Yeah. When n goes to infinity, this term goes to 0, right? So the denominator, the whole denominator goes to 1, right? Yeah, 1. The numerator goes to infinity, right? So that means the whole limit is infinity. When you have f of 2m, oh, I don't know why I cannot erase it. Over equals infinity. Definitely you don't have this condition, right? Yeah. You don't have that condition. The ratio goes to infinity. So the answer is no. It is no. So you can use the limit way to help you check if it is in big theta or not. Okay? All right. So the next one, this question. For this question, we need to use one key formula, n plus 1 ceiling function equals 1 plus floor function. That's the key formula we need to use. With that formula, let us simplify this expression. Okay? All right. Ceiling function. When we start, 2s minus 1. Okay, we apply that formula the first time. This whole thing we can treat as n plus 1, right? Yeah, that's n plus 1. So 1 plus n, so that 2s minus 1 and minus another 1, so minus 2. Okay, yeah. All right, but that 2, we can use property of logarithm. We can take that 2 out, log base 2 of 2, so that's 1. 1 plus s minus 1. All right, so then, because this one, we can pull it out. So we get 2 plus minus 1, right? Okay, all right, yes, but, all right, but, yeah, we want to go back to the ceiling function, right? Go back to ceiling function. All right, so that's the new n. So 1 plus s, right? This time s. Okay, 1 plus s. Oh, yeah, we don't have the ABCD here. Okay, 1 plus. Yeah. Yeah, this question, some problem. Okay, if I put like that, then it will be better. Okay, so let me modify AB option. Yeah, CD we can keep there, right? Yeah, AB option plus 1. Then answer is B. Okay, yeah, I will modify my example. Yeah, so that will be better. Yeah, so you can see this question, we just need to, use this key formula. Yeah. All right, yeah. So let me stop here for our part E.2.